In the previous lesson, we introduced the idea of solving non-right triangles, and we went through the law of sines and used the law of sines when we were given certain parts. Now, there are going to be situations where you're given certain parts of a triangle and it's not going to fit the law of sines or the ability to solve the triangle using the law of sines, and so then we'll just move forward and use the law of cosines whenever we can't use the law of sines. And so you can see in this concept box here, we've given you the formula for the law of cosines based on the labeled triangle to the right. Now, we've also given you an option for looking at the law of cosines in a different method when it's just set up as a cosine statement. Now, here's what I'm going to suggest to you. Learn one of the two. Don't try to memorize both of them, where that would be a little bit of overkill and a little bit confusing. If you learn the first set that are in the concept box, it's very easy to fill that in and solve those and then get cosine of the given angle that you're looking for by itself. So it doesn't require memorizing both. So just make that decision on your own, what you feel most comfortable with, and go from there. Now, as we've done in class before with the law of sines, probably, I would like you to see where this comes from and have a little bit of background knowledge as to how to come up with this information. So I'm going to go to another document here, and I'm going to show you how we developed the law of cosines. Okay, so what I've done is I've taken the original triangle that was labeled A, B, and C, and the sides A, B, and C, and I've cut this triangle with an altitude, and so we will just simply label that new point as D, if you will. Now, from here, since I have two new right triangles, and C encompasses the length of the whole base of the triangle, I went ahead and in blue gave each of those new triangles a new base. So I just used the one on the left, I called it X, and then that means the one on the right could be defined as whatever C is minus X, and so it just gives us the leftovers. Now I'm just going to keep it kind of generic here, and I'm going to use this on each side to basically set up Pythagorean theorem more than anything. So let's take a look at this. On the one on the left, I'm just going to do Pythagorean theorem, and so in this case my hypotenuse is b, so I'm going to say b squared equals x squared plus h squared. So that's no different than c squared equals a squared plus b squared, just using different variables. Okay, I can also really make the statement that we used in the law of sines, but I can make the same statement with the law of with cosines. I can say that the cosine of angle A is equal to the adjacent, which is x, over the hypotenuse. And this from there, I can say that b times the cosine of A equals x. Okay, so that's not a bad start. I've kind of gotten some information from the left side of this particular triangle. Now I'm going to do the same thing on the right side. So I can say, according to Pythagorean theorem, I can say a squared equals c minus x squared plus h squared. Now, if I expand the c minus x, I'm going to have a squared equals c minus x times c minus x plus h squared. And if I FOIL that, I end up with c squared minus 2cx plus x squared, and then on the back end of this, I still have h squared. The reason that I did that is because you can see here, very simply, that I have x squared plus h squared, which is the same as what I had from the previous part. So now I'll just simply substitute that value. So I have a squared equals c squared minus 2cx plus b squared. Also, I have a value for x. In this case, I had x by itself over here, so I can do this substitution process one more time. So I'm going to have c squared minus 2c times b times the cosine of a plus b squared. And now, just to kind of get everything in order and more appropriate way, we can say a squared equals b squared plus c squared minus 2cb times the cosine of a. And that will give us one version of the law of cosines. You'll notice that on the notes we had three sets, or three different versions of the law of cosines, and it's very similar to what we saw in the law of sines, where we had three different ratios. If I wanted to get this in terms of b squared or c squared, I would come back to this original proof and I would just simply draw a different altitude coming from either point A or point B, and I would redo this process until I had b squared or c squared by itself, and it would come out in a similar fashion. So that's a good look to see how we came up with the law of cosines, and it gives you a little background information. So now, that being said, we now know where the law of cosines comes from. We now need to learn how to use it. So in the next video, we'll look at a sample problem.